Okay, 6.4. This is 6.4a. I don't know that it's going to take more than one video, but one of the things that's really important to understand, and I had mentioned it in a previous video, that you look at the radical signs as if they are a variable, and it makes things go so much better. So what that means is, because this number is the same, and the index is the same, I can combine these. So let's pretend that this was 5x minus 4x plus 6x. That would give me 5 minus 4 is 1x plus 6x is 7x. Okay, let's look at the radical. 5 minus 4 is 1 plus 6 is 7. And then we just tag the square root of 3 onto it. We don't do anything with it. We don't add the 3 plus 3 or minus 3 plus 3. We just worry about the numbers in front. So addition and subtraction, these have to be the same. Just like if it was a variable, I could not add these two because the variables are different. An x and a y I can't add, but if they're both x's, I get 9x. So it's just like 5 square root of 3 plus 2 square root of 5. I can't add those because these are not the same. Okay? That's pretty much the key when it comes to adding and subtracting radicals. But you are going to get some, like example 2, that you have 3 square root of 8 plus 5 square root of 18. And at first glance, it's like I can't add those. I'm done. But square root of 8 can be reduced. So you try to find a number, two numbers multiplied together that give you 8, where you can take the square root of 1. I'm going to do the same with this one. So now I can take the square root of 4, and that's 2, and I can pull it out. I can't take the square root of 2, so it stays. I've got 5, square root of 9 is 3. And I can't do anything with that square root. So now I have 6 square root of 2 plus 15 square root of 2. Now I have numbers that are common, so I can add these and get 21 square root of 2. I can actually then add those. So first step, in fact, the rule, middle of page 527, the rule is to add or subtract radicals, put each in simplified form first. Okay, so let's look at example 3. 7 square root of 75 xy cubed minus 4y square root of 12 xy. Okay, so we're going to simplify first. So we're going to look at two numbers multiplied together to give me 75. So that's times 3 xy cubed minus 4y. Two numbers multiplied together give me 12. 6 and 2, nope, those I can't take the square root of one of those. But I can take the square root of 4 times 3xy. Okay, so 7, I'm going to pull the square root of 25 out. And I'm left with 3xy cubed minus 4y. Square root of 4 is 2. Make sure you multiply here when you pull these out. Multiply by whatever was out there already. All right, so that gives me 35 square root of 3xy cubed minus 8y square root of 3xy. Okay, one of the things that keeps me going. If this number here, the index, if this exponent is bigger than the index, I can pull more out because 2 goes into 3 one time, so I can pull that 1y, I can pull 1y out with a remainder of 1. So 1y stays in there. We pulled 2 out, left 1 in. Can't do anything with 3xy over here. But we have a 3xy and a 3xy, so I can take 35y minus 8y And that ends up being my answer, and I'm done. Okay, this is example number 4. Okay, so we got to remember we have cubed roots here. So we're looking for a number that we can multiply by itself 3 times to get 8. And that ends up being 2. So we're going to put that 2 out here because the cubed root of 8 is 2. And that leaves me with an a to the 4th, b squared plus 11a. And is there a cubed root of 27? 3 times 3 is 9 times 3 is 27. So we can pull a 3 out. The cubed root of 27 is 3. And then we're left with an ab squared. Okay, so let's go ahead and write this as 20 cubed root of a to the 4th b squared plus 33a, 11 times 3. Okay, so now let's look at our variables. We're looking for variable or exponents that are bigger than the index. So this is the only one. So 3 goes into 4 one time with 1 left over. So 1 left over there. And holy smokes, this and this are the same. So now I can add these two together and end up getting 20 plus 33 is 53a to the cubed root of ab squared. Now, one of the things that's important to remember, in your final answer, the index has to be bigger than all of the exponents inside the radical sign. Okay, so this is a 2, so that works. If this were a 4, I could reduce it. So because they're all smaller, I'm okay. So one more, example 5, and we will be done with this lesson. So we have the square root of 3 over 2 plus 1 over the square root of 3. So, of course, the book's going to do it a little bit differently than me, but that's okay. So this one is fine. It doesn't have a radical in the bottom, but this one does. So I'm just going to change this one by multiplying top and bottom. So I've got square root of 3 over 2 plus square root of 3 over. When I multiply these, everything comes off of it, and I'm left with 3. Okay, now it's just like any other fraction. In order to add these, we have to have common denominators. Common denominator is 6. So I multiplied 2 times 3 to get 6, so I have to multiply the top by 3. Then I'm going to change this bottom to a 6. I multiplied the 3 times 2 for it to be a 6, so I'm going to put a 2 up on top and multiply it by the numerator. But since I cannot combine the 3 with the square root, I leave it just like that. But because my numbers under the square root sign are the same and I have a common denominator, I can make this 5, 3 plus 2, square root of 3, all over 6. And I'm done. Okay, that's it for 6.4.